Dot skill presents factors. The factors of a number are all the numbers that can divide into the given number without leaving any remainder. For example, the factors of 6 are 1, 2, 3 and 6 because each one of these numbers can divide 6 without leaving a remainder. On the other hand, 4 is not a factor of 6 because if you divide 6 with 4, so if you do this division, 6 divided by 4, you have a remainder of 2. The factors of 9 are 1, 3 and 9 because these are the only 3 numbers that can divide 9 without leaving a remainder. And the factors of, let's say, 12 are 1, 2, 3, 4, 6 and 12 because these are the only numbers that can divide 12 without leaving a remainder. 5 isn't a factor of 12 because 5 times nothing is 12. Or let me be more correct by saying there is no integer that multiplies with 5 to give you 12. Recall that a prime number is a number that has got only 2 factors. And that are 1 and the number itself. For example, 11. The factors of 11 are 1 and 11 only. For example, 17. The factors of 17 are 1 and 17 only. For example, 23. The factors of 23 are 1 and 23 only. 1 is a factor of every number, and the number itself is always a factor of itself because a number can always divide into itself without leaving a remainder. Let me also remind you that even numbers are generally not prime because they always have 2 as one of their factors. In fact, 2 is the only even prime number. 2 is the only even number that's prime. And the reason for that lies in the definition of prime numbers. I said a number that has got only 2 factors, 1 and itself. Now if you think about the factors of 2, 2 has got only 2 factors, 1 and 2. So it's pretty much 1 and itself, and therefore 2 qualifies as a prime number. And the number that's not prime, like 6, 9 and 12, are called composite numbers. Composite numbers are not prime. And by definition, they have at least 3 factors. Now how about the number 1? What are the factors of 1? Well, 1 has got only one factor, 1. So it neither qualifies as a prime number nor as a composite number. 1 is the only integer that's neither prime nor composite. Factors of a number that are prime are called the prime factors of that number. So the prime factors of 6 would be 2 and 3. These are the prime factors of 6. The prime factors of 9 would be 3 only, because 1 is neither prime nor composite, and 9 of course is not a prime number. And then the factors of 12 that are prime are 2, 3, and that's all. So these 2 again are the prime factors of 12. The greatest common factor also called the GCF, sometimes called the GCD, D for divisor, of two or more numbers is the largest number that is a factor of both the numbers. Let me give you an example. The GCF of 6 and 9 is 3 because 3 is the largest number that is a factor of both 6 and 9. Similarly, the GCF of 10 and 15 is 5 because 5 is the largest number that's a factor of both 10 and 15. And the GCF, let's say, of 20 and 50 is 10 because 10 is the largest factor that's common to 20 and 50 both. We could also have GCF of more than two numbers. For example, the GCF, the greatest common factor of, let's say, 12, 20 and 32 would be 4 because 4 is the largest number that's a factor of all these three numbers. So if we were to write down the factors of 12, we have 1, 2, 3, 4, 6 and 12. Similarly, the factors of 20 would be 1, 2, 4, 5, 10 and 20. And the factors of 32 are 1, 2, 4, 8, 16 and 32. Now if you look at the common factors between these three sets, we have a 1 on all three, we have a 2 and we have a 4. So 4 is the largest of them all, largest of the common factors. Reason why we call it the greatest common factor. Time for us to try a word problem. Emma is making lunch packs for her friends who are due to go on a trip. She has 18 bottles of water and 12 cans of soft drink. What is the largest number of packs she can make so that every pack has the same number of water bottles and soft drink as the other packs? So she's got 18 bottles of water and also 12 cans of some soft drink. And she needs to divide these into a certain number of packs. And also keep in mind that all the packs are identical. Each pack has got the same number of water bottles as the others, and each pack has got the same number of cans of soft drink as the others. What is the largest number of packs she could make? Now obviously, if you were to distribute these 18 bottles of water into a certain number of packs, this number of packs has to be a factor of 18. Otherwise, you would have some leftover. For example, you couldn't have 5 packs because there's no way you could divide 18 bottles equally into 5 packs. So the number of packs is a factor of 18. And using the same logic, the number of packs is also a factor of 12. After all, the 12 cans would have to fit into the 5 packs or whatever that number is without leaving any number of cans in the end as a remainder. So we could say the number of packs is a factor of 18 and 12 both. And now if you come to think about the factors of 18, we have 1, 2, 3, not 4, not 5, 6, not 7, not 8, 9 and 18. And similarly the factors of 12 are 1, 2, 3, 4, 6 and 12. But the number of facts has to be a common factor between 18 and 12. Therefore, it could either be 1 or 2 or 3 or 6. That's all. And if you want to find out the largest number of facts, that's the largest common factor between 18 and 12, which is 6. So the answer pretty much is the GCF of these two numbers. 6 facts. Hope that makes sense.